Hello everyone and welcome to my class. Today we will be continuing our class on functions. Alright, so let me share my screen real quick. So can you all see my screen now? If you can see my screen, then say yes in the chat. What is this? Okay, close. Okay. If you can see my screen, then say yes in the chat. If you can't, then say no. Alright. Yes, very good. Okay. So let's begin functions 3. So this is our schedule today. We are going to review properties of functions, and we're going to also be learning. We're going to do some operations on functions problems where you're giving a graph and you have to do some operation on it, how it's going to change and stuff. All right. So let's start reviewing all of our properties, and some of the ones we haven't got to yet, like the absolute value one, so we will also cover that too. So our objective for theorem 1 or property 1 is to find what is y equals f of x plus c. And since f of x equals y, okay, y equals f of x, then basically what we're doing here is y plus c. So what is y plus c? If we had a y plus c on a graph, all right, so let's say we had this graph right here, and the y value at this specific point, let's say, is 0, okay? And if we were to add c on that, then we'd basically be shifting the graph vertically, right? So that is how we get this theorem. All right, so the graph of y equals to f of x plus c can be obtained by shifting the graph vertically. And it's going to be shifted vertically by absolute value of c units. Okay? So basically, if you had c is positive, right? We're adding a positive number to the y value, which means the y value is going to increase. That means we're shifting up. Right? So if c is positive, shift up. So basically, if you shift down, then c is going to be negative. All right, so does everybody get this theorem? Are there any questions? Does anybody have any questions on this theorem? If there are no questions, then I will continue. All right. So our second property, who knows what we do in this second property? What happens when we multiply c times f of x? What happens? Okay. Does anybody know what happens? Yeah, okay. So stretch vertically by a factor of c, or a factor of or compressing it by a factor of c. Very nice. All right, so exactly. And how do we see this? All right, I'm going to give you the same example I gave you last time. We're going to review that. So the example I'm going to give you right now is going to be this one. Okay, hold on. It's going to be like this. It's not working, is it? What if I got a ruler? Does that work? No. Okay. All right, we're going to have this graph. And let's say you wanted, this is y equals f of x. All right, this is y equals f of x. And let's going to find, let's find y equals 2 of f of x. All right, so if this is 2, this is 2, this is 2, 0. Okay, negative 2. Well, no, that one. Okay, so this would be 3, and this is, no. What am I doing here? 1, 2, 3, and 4. Okay. All right. And then we can make our chart. Basically, we're comparing the values of y. All right, and this does not change the domain of anything. All right, so we're not going to get into, we're going to get into the ones that change domain in the next few slides. All right, so because this is not directly like affecting x, okay? Let's say it was f of 2x, then it would directly affect x. Then that would stretch or compress it horizontally. All right, so in this graph, you can see that when x is 0, y is also 0. Well, in fx, and we get 1 and 2, 2 and 0, 3 and negative 2, and 4 and 0. All right, but in 2 of f of x, basically we're going to multiply this value by 2. Okay, so it's going to be 0, 4, 0, negative 4, 0. And we can see here that it stretches vertically, right? Like this. It stretches vertically like that. All right, does everybody see this? All right, this is how we do it. So from this, we can obtain the formula. So the graph of y equals to c times f squared, I mean f of x. What am I saying nowadays? I don't know. The graph of y equals c f of x can be obtained by stretching or compressing obtained by stretching or compressing the graph in a ratio of 1 to absolute value of c. All right, 1 to the absolute value of c vertically. All right, so if c is greater than 1, all right, we're going to stretch. Okay, if c is in between 0 and 1, then compress. Now, does anybody know what happens when c is negative? What happens when c is negative? Does anybody know? What happens when c is negative? Okay, so when c is negative, it does not get bigger. What if you use the text option, type a bunch of dashes or text option? Get a straight line. That's genius. Hold on. Wait, no, not that one. This is so good. Oh, wow. Nice. I'll keep that for future reference. Okay. That's very smart. Never thought of that. I didn't even know there was a text option until now. Okay. So you flip and stretch or compress. That's very good. All right. You flip it, right? You reflect it over the x-axis. So if you had negative 2 times f of x, then you'd get something like this, right? You reflected the points with respect to the x-axis, okay? Next property, y equals f of x minus c, and this changes domain because it affects x, it affects the x directly, okay? So if you had an x value, it's on a, if you have a point on a function and it's, let's say, a point on a function, it's, let's say, yeah, 2, 0, okay? Our point is 2, 0. And if you were to subtract 2 from the x value of this, then you would get 0, 0. So what happens there is you're going to be what? You're going to be shifting it horizontally, right? You'll be shifting it horizontally, but okay. Well, I think that's what, yeah. Okay, so, all right, I can use this. No, not that one. I need to do something else. Okay, this one. Do I just hold it down? No, it doesn't work. Wait, what about the straight line? The one from top to bottom. That, I don't know how to do that. Then, okay, so I get this. Where, okay. How do I move this? I move it here. Okay. All right, we're going to have the same graph as before, same example, okay? Wow. You're a genius, whoever you are. Okay. So the same graph as before. And what if we wanted to find, this is y equals f of x, okay? And what if we wanted to find f of x minus 2, okay? X minus 2. Now, what we need to do here is, I actually made a mistake earlier. You don't just subtract 2 from the x value. You need to find the domain first, right? This actually adds 2 to the x value. Because the domain right here, this is 0 and 4, right? So basically what we're going to do here, we're going to find the domain. Let's call this, okay, g of x. Find g of x, which equals f of x minus 2, okay? So domain of g of x would equal x that is real, a real x. Of course, you need a real x, or it's going to be imaginary or fake, or, of course. So, and then since the f of x is in the domain 0 to 4 inclusive, then g of x would be, you can get the inequality this, okay? Get this inequality. All right, and all we need to do is we need to solve this to find the domain of the new function g of x. And this equals 2 to 6, right? 2 to 6, right? So our new domain is 2 to 6. Okay? So we can see from that we shifted this entire graph by 2 units. Like that. Okay. So from this example, we can find, wait, the text doesn't disappear? Hold on. How are we supposed to do this then? Wait, where's the, what? You know, I'm starting to think this isn't such a good idea anymore. Oh, okay. Do this. I hate this. I'm too lazy to do this. I'll just use my regular lines. Okay, maybe not. Those are even more horrendous than they're supposed to be. Okay, so from this we can get the theorem that the graph of y equals f of x minus c can be obtained by shifting horizontally. If c is positive, shift right. If c is negative, shift left. Because why? Because we did f of x minus 2, right? So, but there's a negative sign here, so make sure you pay attention to that. So basically, if there's a negative something, then it's shifting right. But if there's, let's say, what if we had plus c and we assume c is a positive number, then that would be shift left. Okay, so plus something is shift left, minus something is shift right. Unless c is a negative number, then we can't do anything. Okay, but make sure you understand that f of x minus 2 shift right, f of x plus 2 is shift left. Okay, it's kind of weird here, but that's how it is. If you change the domain. All right, so next theorem, and this also changes the domain. This is theorem 4, and we're going to find y equals f of c of x, cx. Okay, so how we do this, basically this time we're not stretching or shifting vertically anymore. We're going to compress, or we're going to stretch and compress horizontally this time. Okay, so since, recall, we had y equals cf of x. That is shifting or compressing vertically. This is stretching or compressing vertically. This is stretching or compressing horizontally. All right, so the graph of y equals f of cx, and I would encourage you to write all these theorems with me unless you already have them in your notebook from last class, or I would encourage you to write these theorems down because they are very useful when we're learning about more complicated functions, compositions of functions, exponential functions, logarithmic functions, those kind of things. We're going to use these to change the properties of functions. All right. So the graph of y equals f of cx can be obtained by stretching No, there's not a C anymore. Okay. Spelling. Okay. Stretching or compressing. Horizontally. By a ratio okay, so yeah, it's basically almost identical to last theorem, I think. Yeah. No, this one. Okay, this one. Almost identical, okay. Stretching or compressing horizontally by a ratio. I don't think this last part is this valid? I don't know. Okay, maybe not. Because this time it's kind of different when we're doing something directly on X. It's kind of different, so probably not the same. So I will need to actually think about that later. All right, so if, well, horizontally. Okay, failed grammar too, I guess. Set. All right, so or compressing horizontally if C is greater than 1. This time we're actually going to compress, all right? But if C is if C is in between 0 and 1, if C is 0 in between 0 and 1, then you're actually going to stretch. It's pretty weird, right? So let's say you had, let's use this previous example, right? This one. Okay. So let's say we wanted to find y equals f of 2x. Okay, then it's going to change the domain, right? So g of x equals f of 2x, then the domain of g of x equals, for all x's in between 0 and 4, then you would get, okay, you would get a smaller domain, right? Smaller domain that'd be equal to 0 to 2. However, if this was 1/2 of x, then you would get a bigger domain, be 0 to 8, right? So that's how it works, okay? Because you have to change the domain every time. All right, so are there any questions yet? Any questions? Don't do the y-axis. Which y-axis? Okay. All right, so property theorem 5. Y equals the absolute value of f of x. Now this one, I'm tired of writing, okay? Like, actually. So I'm just not gonna write this one. It's your job. You write this one down. Okay. Too lazy today. All right. So let's find this theorem using, what if you find this? Yeah. Let me give you an example. Okay. Okay, so let's say we have that same example from before. Yeah, that same example, all right? And now we're going to find, okay, this is y equals f of x, and this time we're going to find y equals to the absolute value of f of x. So we can create our chart again, and let's see what that looks like. All right, so, oh wait, I can do it for charts too. This is so genius. Okay, so, wait, can I have another text? Oh, I can rotate this too. Oh my god, I can rotate it. Wait, what if I had another text? Can I not have another text? I can only have one text? Seriously? Please help. How do I do this? I hate this. Ah, wait, what if I copied it? Can I copy this? Hold on. Genius moment here. No, never mind. No. Okay. Maybe not. How do I use this thing? All right, so, okay. So let's say when x is 0, then f of x is going to be 0, 2, 0, 2, 0. Okay. So what about absolute value of it, f of x? Then we're going to just take the absolute value of each of these. So 0, 2, 0, 2, 0. Now you can kind of see that it's going to be this exact same thing, except it's going to look like this. All right, like that. All right. So what did we do here? Basically, if you can understand this, we're taking the absolute value of y, basically, because y equals to f of x, right? So we can just substitute it in. We're taking the absolute value of y, and you know that absolute value cannot be negative and has to be positive because it's the absolute distance from 0. Okay, so it cannot be negative. So basically, all of this negative stuff in this previous graph doesn't count. We're not going to need that anymore, okay? It doesn't count because it's negative. So everything has to be reflected with respect to the x-axis to be positive. So if we're going to take the absolute value of all of these negative things, then it's going to be, everything negative is going to be reflected up up with respect to the x-axis. Okay. So does everybody get what I'm saying here? You cannot have a negative y value, so it has to be positive. So let's say we had this y value -2, right? Cannot be positive. Cannot be negative because we're taking the absolute value of it. So we're going to have to make it positive. Okay. So that's why we reflect all of the negative y values with respect to the x-axis. So are there any questions? Any questions so far? If there are no questions, then I'll continue. All right, so this is our last property, and this actually changes domain because this is directly affects x. All right, so let's do this. Y equals f of the value of x, and I'm still too lazy to write anything down, so yeah, you're gonna write things down. Yeah. Yes. Okay. So we're going to, okay, my graphs are dumb again. Okay, that's very sad. Why are these so squiggly? Okay. We're going to have that same exact example, and this time we're going to find y equals f of absolute value of x. Okay? So if we were to find that, we need to find the domain, right? We first need to find the domain, and the domain of f of absolute value of x is going to be this, right? We've learned absolute value of inequalities before, so that's going to be equal to -4 to 4. All right, so are there any questions on this part so far? Okay, so now you can see that the domain expanded, right? And right now we can see that what we're going to do here is we're going to reflect it over the y-axis, right? We're going to reflect it over the y-axis, okay? So then, how do we obtain this? Because we got our domain, right? It's enlarged. It covers both the negative and the positive part, all right? Okay, so are there any questions on this theorem? If we're going to have y equals to f of absolute value of x, then we're going to have this, okay? Any questions? Actually, I think I should actually create a chart to make you understand better. So, hold on, let me create a chart here. So, since now the domain is enlarged, you can see for -4, -3, -2, -1, 0, okay? Since it's taking the absolute value of x, then basically what we're doing here is still f of 4, still f of 3, and still f of 2, and so on, okay? So that is why we obtain this graph here. All right, so now we're done with our properties. So now we're going to go on to some problems. Okay, so the graph of f is as shown. Okay, so I'm going to draw you a graph, and you're going to sketch the graph of y equals to f of absolute value of x. All right, so does anybody know how you can copy this text box? And how do I make more text boxes? So far, if I click off of this, I can only create one. Okay, so what if no. What is Spotify on here? Okay, so I'm just going to do that for now, and we're going to have this graph here. This graph here. No, that's not good. Okay. No, that's still not good. That's horrible. Okay. Perfect. So let's graph. This is y equals to f of x, and you're going to sketch the graph of y equals f of absolute value of x. All right. So let's begin. I'll give you a few moments to solve this one. All right, we have one answer. Hopefully if it's an answer. Try hitting the clipboard on the text pop up. Clipboard. No, doesn't work. Clipboard. Already tried it. How do you... Okay. Oh wait, this is fun. What? No. Basically, if I draw something, let's say an A, it's an A, B, C, D, E, F, G. Oh, that's nice. Okay. Don't have any really use for that anyways. I just need to know how to copy this or make another text box. What's wrong with this thing? How do I make another text box? Oh, clipboard. What's this? Clipboard. No, that's not gonna work. Okay. Any answers now? Yeah, I don't know what clipboard is. I thought it meant copy too, so this is weird. Are there any answers yet? Oh wait, you can't do that. Okay. Right, you have to graph it. But I hope you have the answer on your notebooks already, so let's do this. Basically, if you're going to have the absolute value of x, then negative x is not possible. So this part is kind of irrelevant, right? Yeah. Hold on. This part is kind of irrelevant. Because x cannot be negative, right? Because we're absolute value. We're getting the absolute value of x. So the answer to this, since we're going to reflect it, would be this. All right. So are there any questions on how we obtain this graph? No questions? Hopefully. Okay, no questions. Not yet. Well, hopefully not yet. Okay, so next problem. The graph of f is as shown. Sketch the graph of y equals f of 2x minus 1. All right, so how are we going to do this? Basically, we are going to do this. First, what do? First, we have to determine the domain, right? We're going to have to determine the domain. So, the domain of f of 2x minus 1 equals what? Can anybody tell me which inequality should I set up? Which one should I set up? Which inequality? What inequality should I set up to find the domain? Does anybody know how we're going to do how we're going to find the domain? Anyone? Okay, so basically we're going to do, oh wait, the graph of SF isn't shown. Oh well. It's the same one as last time. I'm too lazy. Yeah, okay, let's do that one. Okay, so moving on. It's gonna be 0 to 2x minus 1. Right, like that, right? Okay, after we set our inequality, it's gonna be what? I'm gonna solve it, right? I'm gonna solve it, and we're going to get 1/2 to 5/2. Okay, so that is our new domain. It's actually, let me make a chart here. And if you see all of these operations, we've learned this already, right? We've learned all of these operations already. So basically, what we're going to do here is order of operations, all right? So order of operations says you need to do multiplication first. All right, so let's do that. And if you multiply 2 to x, what is that going to give you? You're going to compress it, right? Going to compress it. Okay. So how are we going to do this then? Compress. Well, usually if you compress it, then it's gonna, if this one is from 0 to 4, then it would be from 0 to 2. So if you compress it, it'll look like this, right? Like this. But we also know that we have to fit this domain right here. So the graph of it would look like this. Okay? This is a 2, this is 5 over 2. So this is our graph. Okay, so now on to, this isn't very difficult stuff. So now let's do this one. All right, this one should be quite challenging. Okay. So does anybody know how to do this one? I'll give you a few moments to do this one. All right, if you have any questions, let me know. Okay. All right, so are there any answers? Okay, we have one answer. 0, 7. All right, 0, 7. Are there any other answers? Any other answers? Does anybody have any answers? All right. Very good. 0, 7. That is actually the correct answer. Very good. So could you please explain to me how you got that answer? How did you get that answer? Okay, which method do you use? I currently know 2 methods how I could do this one. One is the very slow and stupid one. One is the other one, the fast and smart one, the one that I use naturally. Okay, so how would you do this one? Would you go the slow way, and you would actually sketch P on a coordinate graph, and then you would do all these operations on it? Would you do that? Or would you do the fast way? Do you even know the fast way? Okay, so did you sketch it on a coordinate graph and do all of these operations on it? Or the other one? So you did it mentally, of course you did. Well, I guess you could, right? If you subbed in all of these, wait, hold on, let me try this actually. If you subbed in, okay, so okay, -4, 2, okay, I'm not doing this. This is dumb. Mentally, I guess you could do it mentally. -2 and 3, yeah, you could. You could first do like shift it right by 2, so it'd be 0 to 5. I mean, no, just 0.003, and then multiply by 2. Okay, 0.6 plus 1, 0.7. Oh wait, that's actually quite fast. Guess there's 3 methods now. Oh wait, no, that's not really a method. Not really. You can just do it mentally. Well, what if I give you an even harder problem? Then probably be pretty hard to do. Then okay, so let me introduce this fast method. Okay, fast method. So what does it mean for P to be on the graph of F? Okay, that means that F of -2 equals 3, and this is the key here. We need to know this. All right, so since F of X is okay, so since F of X, that's going to be equal to 2 of X, 2 of F of X, 2 times F of X minus 2 plus 1, then we can do this. I'm not going to worry about what's inside the parentheses yet. So let's do 2f of -2 equals, what does that equal? Okay, 2 times 3 plus 1 equals 7. All right, because this is the y value. Since this is the y values, then we don't have to worry about in the parentheses, right? We don't have to worry about it, okay? Because we're just changing the y value now, so that what's in the parentheses doesn't matter. Okay, so y value 7. What about x? Well, x minus 2. That's in the parentheses, so we have to worry about that to find the x value. So what is the current x value? Okay. Okay, we're going to set that equal to what? Set that equal to 2, right? We're going to set that equal to 2, then we get x equals 0, right? So are there any questions on this method? Okay, I assume there are no messages and I just want to go already. I'm so bored. Okay, yeah. Oh well. Let me just go already. Alright, kids. Alright, kids. I'm out of here. Oh wait, some of you are the same age, of course. Okay. What am I supposed to do here? Alright, bye. Okay, I'll see you next time, okay? Oh wait, you need to see the ending screen. No, it's mediocre. Okay, let's not do that. Oh well, I'll see you next time. Maybe. Unless you get hit in a car crash. I've been contemplating about my life choices recently. I don't know why.